Here we have a beautiful predator and parasitoid, Ampulex compressa, commonly known as the emerald cockroach wasp or jewel wasp. She is looking for something incredibly important, a food source for her unborn young. Adult and larval jewel wasps respond to cariomones, or visual cues associated with their prey.
She has found it, an American cockroach. But she must be very careful, since the roach is much bigger than she is. Ampulex compressa specializes on adult cockroaches of the genus Paraplaneta. Unlike generalist parasitoids, the jewel wasp follows a specific innate set of host handling behaviors.
She attacks swiftly and strategically. She will deliver 2 very specific stings, and she must get the first one right if she is to succeed.
The wasp stings the cockroach in the prothoracic ganglion, delivering a dose of gamma-aminobutyric acid, taurine, and beta-alanine. This induces 2 to 3 minutes of transient flaccid paralysis of the front legs by causing a postsynaptic block of the central cholinergic synaptic transmission, blocking all motor action potentials and depressing chloride conduction down the synapses.
This paralysis only lasts a couple of minutes, but that is all she needs to deliver the most important sting of all, right into the ventral side of the head and into the subesophageal ganglion, or SEG, of the cockroach's brain.
She injects a procaine-like substance. Procaine is commonly used as an anesthetic in humans, increasing dopamine and serotonin production.
This causes the roach to compulsively clean itself and slows the roach's metabolism. This means that the roach will not use up its nutrient reserves as quickly as normal, and that the wasp larva will have a more nutrient-rich host. Having the roach clean its own body helps ensure that no bacterial infections will harm the delicate wasp larva. The venom also inhibits octopamine activity, which is responsible for muscle control. This is what causes the sustained lethargic state of the roach, characterized by hypokinesia and a lack of escape response, although the insect is no longer paralyzed. The wasp has a unique way of testing to see if she has delivered the optimal amount of venom. She snips the ends of the roach's antennae and feeds on its hemolymph to determine the venom's concentration in the roach's body. If it is too little, the roach could recover and escape before it has fulfilled its purpose. Too much and it will die, and her young's food source will decay.
She drags the drugged roach to her burrow and leads it inside.
She lays a single egg on the roach's cuticle.
The female wasp will repeat this process and lay several more eggs over the course of her lifetime.
Then she barricades the entrance to ensure the roach won't be able to escape, and then no other predators threaten her young.
The cockroach has had a very bad day, but it will get worse.
Once the wasp larva hatches, the cockroach serves as an immobilized fresh food source and microenvironment for development. Roaches live a very unsanitary lifestyle and often carry a plethora of bacteria and fungi. Predators that feed on roaches are at great risk of infection. The roach's induced grooming behavior helps begin the sanitization process of the host, but during development and metamorphosis, the wasp larva must compete with microorganisms for food. In order to ensure its survival, the larva injects a blend of gamma-lactones and isocoumarins into the roach's body to hamper the growth of microorganisms and fungi, such as entomopathogens.
It begins feeding on the bodily fluids of the cockroach. Then it burrows inside and begins eating the roach from the inside out. Remember, the roach is still alive and unable to respond. The larva leaves the respiratory and nervous system for last to ensure the roach survives as long as possible. When it's ready, the pupa builds its cocoon inside the roach and develops into an adult jewel wasp.
A new jewel wasp emerges from the burrow, ready to begin the cycle over again, leaving behind nothing but an empty husk of a cockroach.